Hello, I'm Leo from Sysmo, and today I will talk about ZK Attesters. So, at Sysmo, we are doing a modular attestations protocol focused on decentralization, privacy, and usability. So first, what is an attestation? An attestation is a certificate about a fact. For instance, I voted in the ENS Constitution DAO. I am an Ethereum staker. I made more than 500 transactions. I have more than 10,000 followers from my Twitter account. I am active in 3 DAOs. I have verified phone numbers. So all these attestations, we want to put them in the same contract on-chain, what we call an attestations registry. Why that? Because we want to have consumers of these attestations. For instance, we can have snapshot-based voting on an attestations, and if this attestation is a ZK attestation, that means we don't know really who is the address that voted in the ENS Constitution DAO, we will have totally privacy voting. You could also have gated channel with guild XYZ or privacy airdrop and stuff like that. In the other side, you have issuers. The issuers are attesters, ZK attesters that are privacy-based, or bridges, and all different type of issuers that can write in this attestations registry. So, what is a ZK attester? A ZK attester issues attestations. So it verifies user requests, and these user requests are backed by a ZK proof, and this ZK proof comes from a particular ZK scheme. So what we call a ZK scheme, it's just a proving mechanism using zero-knowledge proof. So for instance, you have the prover that makes the proof and the verifier that verifies the proof. So I think you all know this very well, but what we really like for ZK attesters is that your prover is in the border. So it can be computed on your border for privacy reason, and that your verifier is a smart contract that can verify the proof on-chain. So what we are trying to do at Sysmo is to experiment with different types of ZK schemes. It's really an experimentation. We really want to find real usage with these attestations. Is really privacy voting interesting? Is access gated channel really interesting? We don't really know. We want to test that. And we are really pragmatic and impact oriented. So to talk about the main problem for this attestation is the proof of ownership. When we say I voted in the ENS Constitution DAO, I voted, so that means I own an Ethereum address, and this Ethereum address is part of a group of all addresses that voted in the ENS Constitution DAO. So to do that inside a zero-knowledge proof, you need to verify the CDSA signature in a zero-knowledge, and this verification should be computed in a border, and you need a nullifier to be Sybil resistant. That means to avoid to have a lot of different attestations for the same source account. So the problem is that the first one is hard. In fact, it's less and less hard because I think you did an amazing job, and now I know that you worked a lot on this, and the border verification of ECDSI is really faster. But we still have the problem of how we are going to compute this nullifier, because the private key is stored in wallet, so in hot wallet or cold wallet, but we don't have access to this private key. Yeah, so the nullifier part is for the Sybil resistance. The Cabal project of their Xpark really worked around that, and for having access to the private key, they use the MetaMask snaps feature. But the problem is that this snap feature is not going to be usable for everyone in short term, and you still have the ledger, cold wallet where you won't be able to access the private key. So one workaround you could have is using commitment scheme. We are going to see two different types of commitment scheme: Semaphore and Hydra S1. So Semaphore is a commitment scheme that was developed by the Ethereum Foundation, and Hydra S1 is a commitment scheme that we developed at Sysmo. So it's just a comparison between the two schemes and to find the different trade-offs they have. They have different trade-offs, but these two ZK schemes could be implemented and will be implemented as a ZK attester because they have trade-offs that are interesting. So in Semaphore, you first create a Semaphore identity. You then join a Semaphore group with this identity, and you are able to prove that this identity is part of the group, and you will be able to get a nullifier for this proof. So the Semaphore identity is constituted of an identity trapdoor, an identity nullifier. They are just secrets only known by the user and generated in the browser, for instance. And then you have an identity commitment, which is a hash of these two secrets. When you want to join a group, you will add your identity commitment in the Semaphore group. So it's an on-chain incremental Merkle tree. So it's basically something like that. And then when you want to prove that you are part of this group, you are going to do a proof with a zero-knowledge circuit where you compute the identity commitment inside the zero-knowledge to prove that you are the only one knowing the identity nullifier and the identity trapdoor. You verify the identity commitment is inside the group thanks to a Merkle inclusion proof. And then you also verify that the nullifier hash was well computed using the external nullifier and the identity nullifier. So what we can see here is that in the commitment scheme is because you know the secret that made the commitment, that you are able to prove that you made the commitment, and that the nullifier hash was well computed. So here, pros and cons of Semaphore. So it's fully decentralized, so it's really, really powerful. But you have an anonymity set, and this anonymity set also, you have some waiting time. Why? Because it's like Tornado Cash. When you are doing a deposit, you need to wait before doing a withdrawal. It's exactly the same. When you are joining a group, you need to wait before using your proof. Otherwise, you can have statistical attack on the proof. And also, you have the identity secret to handle. So when you use directly your ECDSA address, it's easier because we all have MetaMask or Ledger or whatever. Here you have to have another system to handle your secret. So in Hydra S1, it's a little bit different because we have first groups of accounts that are generated with publicly available data. It's totally distinct from the commitment. So this is handled by a Sysmo infrastructure, and it's open source and publicly verifiable. And then a user needs to make a unique off-chain commitment for an address. That means he will associate a commitment with an address just one time. And then he will be able to prove that an address of himself is part of the group and get a nullifier for that. So here, what is groups of accounts? So it's basically just addresses and values. For instance, value, if you have a group of, punk owner, the value will be the number of punk you own, and the addresses will be all the addresses that are part of that own a punk, so something like 3,000 addresses. So this can be made publicly with a snapshot API, BigQuery, subgraph, stuff like that. And they are formatted in binary Merkle trees, where the leaf is the hash of the address and the value. And the group, the root of this group will be periodically updated on-chain with an infrastructure, an off-chain infrastructure. So now the off-chain commitment, how it works. So in his browser, the user just take a secret and hash this secret to have a commitment. He will then send this commitment along an address and an address signature to prove that he owns this address. The Offchain Commitment mapper will map the address and the commitment in a KV store, basically. And you can have only one commitment for one address, otherwise it's throw. If all is good, the commitment mapper will send back a commitment receipt, which is an EDDSA signature of the address and the commitment. So the EDDSA is really easy to verify inside, for instance, Circom. And in the Hydra S1 circuit, we will verify that the commitment was well made with the hash of a secret. So the user well known the secret, and he is the only one to know this secret. We verify the commitment receipt is well signed by the commitment mapper, that ensure the commitment well goes to the commitment mapper and was approved. And then we will verify that the address is part of the group and the address is well owned by the owner of the secrets. And finally, we compute the nullifier hash like Semaphore with the secret, so hash of a secret and an external nullifier. So we have the same structure with the secret that prove you own the commitment and then the address, and the secret that prove that allow to compute a nullifier hash. So the pro and cons here we have is, so for the pro, we have no waiting time because the anonymity set is private. And you can have dynamic groups because your groups can be computed totally distinct fully from the commitment. Then on cons, you have the same problem as the Semaphore. You need to handle your secrets. And the commitment mapper is wholly trusted. So if we do a sum up of these two comparisons, the address ownership is verified thanks to an on-chain commitment on Semaphore, an off-chain commitment on Hydra S1. The commitment proof to prove that you well committed on Semaphore is made through a Merkle inclusion proof, whereas in Hydra S1 it's an EDDSA signature that is verified. And then your groups is static on Semaphore. Static means the user need to do an action to enter a group each time he wants to enter a group. And in the Hydra S1, it's dynamic. That means user just need to go once through the commitment mapper, and he will be able to use his address on all different type of groups, and this group can be updated at a particular frequency. So yeah, it's two different ZK schemes with different trade-off, and both can be used as a ZK attesters. For instance, Semaphore can be for really more critical application because it's fully decentralized, and Hydra S1 could be for more UX-friendly application and stuff like that. So yes, maybe for questions.
There's a question on the Twitter bot. So a wizard says, Leo, what's your intuition about the most compelling use cases for ZK attesters?
Yeah, okay. So we really like to try some private voting using snapshots. So for instance, the Hydra S1 was made for the first ZK attester we made to just find the use case of the ZK attesters. And the first attestation we released was Ethereum power users. So it's a group made of all the top users, the top accounts that made the more transaction on-chain since the beginning. And with this, users can create their attestation that are really private, so we don't know who they are, and we are going to plug this really easily to a snapshot to do voting on that. We can do a lot of different type of proposal on snapshot, and we also did a gated channel on our Discord to try.
actually have a like daily use case for this kind of attestation. So I want to prove I own some NFT, but I don't want to disclose my wallet address. I think that's a very good use case for this, right?
Yeah, true. So this is part of the use case. The only difference is that you need to refresh really frequently your attestation, but an attestation has a timestamp, so you can just ask for a fresh timestamp on your attestation, and then you will be able to prove that for some duration, for instance.
Yeah, makes sense, because we need to like prove our ownership of some NFT daily on this Discord servers.
Yeah, so.
So I was wondering if you have like plans to support kind of like quantitative data in the commitment, right? So like, you know, right now it seems like you can prove that you're a member of a group, but it seems like the static groups would be more flexible if you could, you know, prove that you are a member of a group that, you know, is verified that you have X, you know, ether, right? And you can dynamically form groups based on, you know, quantity ranges, right? After the commitment is created. So I guess I was wondering, like, is this something you see being possible in the near future? And like, how do you see someone specifying kind of what properties they want out of a commitment, like dynamically, if that's possible? I don't know if that makes sense.
Yeah, sorry, it was not so clear for me, but yeah, can you repeat it?
Yeah, sorry. Basically, you can have a commitment to, like, you know, you have 100 ether in your account, right?
Yeah.
But like maybe later I want to only allow people who have more than 10 ether in their account to join my service, right? Is there a way to have someone attest to the fact that I have 132 ether, and then later reveal that I only have, or, you know, only the data that I have over 10 ether without revealing my actual balance, right?
With this type of commitment, you are just doing a commitment to associate your address to the commitment. Then with this commitment, you can prove that you are part of any groups where your address is inside. So then in the groups of accounts in the address one is constituted of an address and a value. So for instance, if you have a groups of, I don't know, the Ethereum transactions number you made, in the address one, you will be able to choose if you want to reveal what value you want to reveal inside this group. For instance, you will be able to prove that you own at least 100, that you made at least 100 transactions in this group without revealing exactly how many you did.
Okay, yeah, cool, thanks.
I have more of a comment, or maybe it's a question. But like, how important do you think it is to have, like, it seems like we have a lot of sources of reputation. Like, how important do you see like having like uses and sinks for those reputations?
Yeah, so for the address one, we are using currently we are using only Ethereum accounts, but we are trying to develop other type of ZK schemes where you can use other type of sources as Web 2 sources, like you will be able to prove some, for instance, you have a Twitter account, and with this Twitter account, you are part of the people that are following, I don't know, their Spark on Twitter and stuff like that. So we want to add a lot of different sources, and in our UI, in our product, we have a what we call a Sysmo Vault, where you can add all your sources that stay only in your front end. And with this, you will be able to generate a lot of different type of attestation with different type of ZK schemes. So,
Great. Thank you.